Welcome to this video. In here, we're going to introduce binomial and geometric distribution. So this is unit for part 3, binomial and geometric random variables, also known as DRV. We're going to start with binomial distributions. If 4 specific conditions exist, a random variable is called a binomial random variable. The 4 conditions are those 4. First, there is a fixed number of trials. Second, each observation can be classified as a success or a failure. Third, the observations must be independent. Fourth, the probability of success, P, is the same for each trial. So whenever you met a distribution, just ask yourself in your mind, did this scenario met these 4 conditions? If it does not, then it's not a binomial distribution. So let's take a look at this example. Mickey and Minnie will have 4 children. They want to create the probability distribution for a random variable x, where x is equal to the number of blue-eyed children among their offspring. So the probability of blue eyes will be 0.25, because from biological perspective, we know that the probability of getting blue eyes and non-blue eyes will be the same for each child. And since they have 4 child, they will have 4 child, so it will be 0.25 for each. Right now, we're going to ask ourselves, is this binomial? First of all, check, is there a fixed number n equal to 4? Well, it is. Success and failures. The success is blue eyes and failure is not blue eyes. So there's not a third option for us. So that's a check mark. Are they independent to each other? Well, it is. Every child is independent to each other. Probability of success is 0.25 for all trials. So that is also correct. Therefore, the binomial is met. Therefore, it is a binomial distribution. And let's create a table for this. The table is 0, 1, 2, 3, 4. We labeled each number. So think about this. The probability of x equal to 0, this will be 0.75 raised to the 4th power. So this is this happens when none of their children have blue eyes. So 0 child has blue eyes. This is 1 child has blue eyes, 2 child have blue eyes, 3 childs have blue eyes, and 4 childs have blue eyes. And what is the probability of all of their childs has blue eyes? Well, that will be 0.25 raised to the 4th power. Because think about that. Basically, we're doing, we're first finding the individual person, like individual people having blue eyes, and raised to the 4th power, because we are doing 4 individuals. And what is the probability of only 1 child has blue eyes? Well, that needs to have some formulas right here. There's formula involved. So this is the formula that we're using for binomial distribution. Just remember this. Whenever we want to find the probability of x equal to r, then we're using NCR. You can type this into your calculator, times PR times 1 minus p and minus r. So this p right here is the probability of having of success. So plug in the values into this formula, we get probability of x equal to 1 is equal to, there's 4 total childs, so 4c1 times 0.75 raised to the 3rd power. Well, this is, okay, so p is actually not the, p is the probability of success. Okay, so 0.75 raised to the 3rd power times 0.25. Yep. Okay, so and then just doing the same thing for the rest of the values, plugging the values into here. And finally, we get all of those probabilities. We can fill out the table right here. Important note about your calculator. Binomial CDF is help you to find binomial probability density function. This is the binomial probability density function. And binomial PDF, you're going to type, not type, but what you're going to write out is N, P, and R. And don't forget the labels, because whenever you use your calculator to help you get these values, you have to make sure that you label all of those values and with units. So N is the number of trials, P parentheses S is equal to P, P depends on the question, R is the number of success. Okay. So let's moving on. Mean and standard deviation of a binomial random variable. There are special formulas for the mean and standard deviation of a binomial random variable. The the durations of these formulas are provided one page on page 450 of our textbook, in case you're included to investigate further. Okay, so for the people who are watching this video right now, just ignore this line. I will teach you later. So probability of success, also known as P, and probability of failure, we can use Q to represent that. Expected value of x, also known as mu sub x, is equal to n times p. The standard deviation of x is square root of n times p times 1 minus p. 1 minus p is also known as q, because probability of success and failure always add up to 1. Therefore, we can also shorthand it to be square root of npq. So for Mickey and Minnie, from the preceding page, the expected value of x is equal to 4 times 0.25, equal to 1. Therefore, it's one child with blue eyes. The standard deviation of x is equal to 4 times 0.25 times 0.75. It's 0.866. That's the standard deviation. A second important note about your calculator, binomial CDF NPR, binomial cumulative function, probability of x less than or equal to r. So basically what this binomial CDF NPR stands for is you're getting the probability of x less than or equal to r. So r is your maximum value. You cannot exceed. Okay. This is another example. So Molly's free throws follow a binomial distribution with probability equal to 0.88. She attempts 50 free throws. And those are some probabilities that you can feel free to do on your calculator just for more practice. Yeah, okay, I think I forgot. Okay, so here is a little practice for this. So we know that binomial CDF, it's basically an area. If it's binomial PDF, then it's asking you what is the probability of getting exactly that value. But if it's a CDF, then what's the probability of getting less than or equal to that value? So here are two examples for you to practice. Finding the probability of x less than or equal to 3. 3 will be r. Binomial CDF, you will type 4.25 and 3. So this is what we try to find. Well, what is the probability of getting at least, not at least, but like at most, 3 childs with blue eyes from Mickey and Minnie? Well, the probability will be 0.996. And probability of getting at most 2 childs for Mickey and Minnie with blue eyes will be using binomial CDF 4.25 and 2. You can feel free to plug into your calculator to see what's the answer for this. Okay, so going back to this basketball player question, a basketball player typically makes 82% of his free throws. He shoots 8 times, assuming each throw is independent. Find part A, the probability that he makes 5 out of the 8 shots. So we're gonna plug in N, P, and R for this. So using binomial PDF, because in this case, we only want to know that he makes 5 out of the 8 shots. So that's a hint for us to use PDF instead of CDF. N equal to 8 trials. Probability of success is 0.82. R is equal to 5 shots made. And plug in all to your calculator, we get 0.1211. Part B, the probability that he makes 2 of the shots. So that's an also PDF problem. Plug in 8.82 and 2, you get 0.0006. Part C, the probability that he misses 6 out of the shots. That's also PDF. So using A, but this case, instead of using the probability of successfully make free throws, we want to know he misses free throws. Therefore, we're going to use 1 minus 0.82 first to find the probability of miss 1 shot, and plugging that into our formula, we get 0.0006. Part D, the probability that he makes more than 5 of the shots. Well, here is an inequality hint. Therefore, we're going to use binomial CDF. The probability of x greater than 5 is equal to 1 minus probability of x less than or equal to 5. So you can use 1 minus binomial CDF of 8.82 and 5. Therefore, you get 0.8392. So there's a hint for you. Because CDF is always represents at most value, so you have to convert it to a less than or equal to instead of greater than for every question you met. So just do it, follow this pattern, and you will get the answer. Part E, the probability that he makes at least 3 shots. So we're asking to find the probability of x greater than or equal to 3, but we don't have the formula for greater than or equal to. Therefore, we have to convert it to less than or equal to. Well, think about that. What is the opposite of greater than or equal to 3? Well, 3 is already included, so we cannot say less than or equal to 3. We're going to move down one value, which is less than or equal to 2. Therefore, you get the value is 0.9993. Part F, the probability that he makes fewer than 5 photo shots. We want to know probability of x less than 5. So pay attention here, there's only fewer than, so we don't include 5. Therefore, it's the same as probability of x less than or equal to 4. Plug in all of the values into your calculator, you get 0.0397. And I added one more question, part G. Find the expected shots makes. Okay, so expected value of the shots. Sorry, it was kind of bad handwriting right here. So therefore, you're going to use your formula. So mu is equal to NP. Use 8 trials times probability of success for each trial. You get 6.56. Okay. And we're going to skip for this right now. Geometric random variables. Moving on. If 4 specific conditions exist, a random variable is called a geometric random variable. The 4 conditions are, first, the variable of interest x is the number of trials until the first success. Okay, pay attention to the difference with binomial. So in here, instead of using the fixed trials, we're using the trials that until the first success. Second, each observation can be classified as a success or a failure. That's the same compared to a binomial. 3. The observations must be independent. That's also the same. Fourth, the probability of success P is the same for each trial. That's also the same. So the only difference is condition 1, but it will make a significant difference, you can see later, compared to binomial. So take a look at the example. Same as Mickey and Minnie will have child until they have their first blue-eyed children. Let's build the probability distribution. So same thing. For example, if the child have blue eyes is their first child, what's the probability? If the child has blue eyes is their second child, what's the probability? And so on. And we cannot have 5 because they only have 4 child. So the maximum is the 4th child. Remember, we don't have the 0 in here. Like the last example, we have 0, but we don't have. The reason is geometric. They only cared about the number of trials you're gonna win through until you get first success. So if you didn't win through any trials or you don't have any children who have blue eyes, then that doesn't really make sense. Like it does not change any probability stuff. So we're just gonna ignore that for as if for right now. So same thing, we're gonna find the probability for each. This is the formula that we're gonna use to find a geometric distribution. Probability of x equal to r is equal to 1 minus p raised to the r minus 1 times p. Just remember this formula, or like essentially you don't have to memorize it, because I think if you're taking an AP exam, the packet will include this, but just know it and know how to use it. So apply the formula to here. When the probability of x is equal to 2, you're going to use 0.75 raised to the 2 minus 1, which is the same thing as first power, times 0.25. You will get the probability in here, 0.1875. So on, like this. An important note about your calculator is geometric PDF PR. This is the same thing as writing out the probability of x equal to r. Geometric CDF PR is the same thing as probability of x less than or equal to r. And don't forget the labels, just as we did previously. Have to label P and R. Instead of this case, we don't have N. So mean and standard deviation of a geometric random variable. There are special formulas for the mean and standard deviation of geometric random variable. The derivations of these formulas are provided on page 469 of our textbook in case you're inclined to investigate further. Okay, so for people who are watching this, like don't know me, you don't have to just ignore this line. So this is the formula that we cared about. The expected value of x is equal to mu sub x, also equal to 1 over p. Standard deviation of x is equal to the square root of 1 minus p. Remember, 1 minus p is also q, so it can also be written as the square root of q over p. So for Mickey and Minnie from the preceding page, expected value is equal to 1 over 0.25, which is 4. The standard deviation is square root of 0.75 over 0.25, which is 3.46. Those are for the geometric distribution. The last one we did is for binomial distribution. The final important note about your calculator for this chapter, okay, I think we don't have that note right here, but like all of the notes that I write before, like those are very important. And if you remember those, I think you won't have any questions further. Okay, let's do a couple questions. Practices. What is the probability that her first miss will occur? Okay, so this is the example. Molly shoots free throws p equal to 0.8 until she misses for the first time. On her fifth attempt, well, this is the same thing as doing the geometric distribution for p parentheses x equal to 5, because the question gives you until she misses for the first time. It's a hint for you to use geometric. The part B says before her fifth attempt, so probability of x less than 5. Remember before just means less than, there's no equal to it, and this is the same thing as probability of x less than or equal to 4. Part C, on or after her seventh attempt. So this is probability of x greater than or equal to 7. So how are we going to convert it in order for us to use geometric CDF? Well, think about this. Greater than or equal to 7. How to convert it to less than or equal to what number? Well, we cannot include 7 because it's already included right here. Therefore, the next value will be 6. So not next value, but the previous value will be 6. Therefore, it's the same thing as probability of x less than or equal to 6. Like 1 minus probability of x less than or equal to 6. Okay, part D, after her fourth but before her ninth attempt. Okay, this is a little bit tricky, but it's not so bad because you're just going to have to know that x lies between 4 and 9. And we're going to use probability of x less than or equal to 9. Because if x is less than 9, then probability of x less than or equal to 9 minus probability of x less than or equal to 4. It's the... Okay, so because in here, I kind of divided into two parts. X is greater than 4. We're going to use x less than or equal to 4. So that's the same thing as 1 minus x less than or equal to 4 is the same thing as probability of x greater than 4. And for x less than 9, we're not going to change anything, but instead of just adding a equal sign right here. Or you can also write them out. What's between 4 and 9 is 5, 6, 7, 8, so you can add them together, but for example, if it's asking you for 10 to 1,000, it will definitely be a lot easier to remember those formulas. So this formula will help you to find any numbers that between two values. Okay, and that's it for this lesson. I hope it gives you a good sense of how binomial distribution and geometric distribution works and what it actually means, what are some things you're going to pay attention to when you're doing the questions, and thank you so much for watching.